Hi everybody. In this video we're going to take a look at how to recognize single replacement reactions and how to predict the products for them. So the first thing we're going to take a look at is how to recognize them. What you're going to always find is that both sides of the equation are going to have an element plus a compound. Now let's consider how to predict the products. Let's use an example to illustrate these three main points. We first find the element that's listed on the reactant side, which in this case is zinc. Now since zinc is a metal, and metals replace metals, that zinc is going to be replacing the silver. So we're going to need to make a compound that contains the zinc and the NO3. The silver is the part that gets kicked out and becomes an element on the product side. Now before we go and write the formula for zinc nitrate, let's do a T-chart. Zinc has a charge of 2+, and nitrate is a polyatomic ion and has a charge of 1-. Using our little crisscross chart, we can see it will have 1 zinc and we'll have 2 nitrates. So our formula will look like this. Once we have the skeleton structure set, then we can work on balancing the equation to balance off the nitrates. I can put a 2 in front of AgNO3. Then to fix the silvers, I can put a 2 in front of the Ag on the product side. Let's revisit the three main points. So we know that metals replace metals, and so zinc, the element that's on the reactant side, had to replace silver. So zinc nitrate was formed, and every time you form a compound, we have to balance the charges for that compound. All the compounds that are going to be formed in this way are going to be ionic compounds, and we'll have to get the charges to neutralize out. Now the single element, we just have to check to see if it's one of the diatomic elements, and silver is not a diatomic element, and so we do not get a subscript of 2. And the last step is always going to be to balance the equation. Let's try another example. So in this example we have F2 as the element, and that happens to be a nonmetal. So the fluorine is going to replace the chlorine. Our new compound is going to have sodium and fluorine, and the chlorine is the one that gets kicked out. So before we can move on to balancing though, let's check to make sure our formulas are written correctly in the skeleton equation. So for every compound, you're going to have to do a T-chart. So in the T-chart, sodium has a charge of +1 and fluorine has a charge of -1. And we get those charges by looking at the location on the periodic table. So what we can see here is that there are no subscripts that are going to be needed, and the formula is just simply NaF as written. For individual elements like chlorine, we just have to check to see if it's one of the diatomics, and in this case it is, so we'll give it a subscript of 2. So now we have a completed skeleton equation, and the last step is going to be to do the balancing. I think I'll just work left to right on this one, and we have 2 fluorines on the left, so I'll put a 2 out in front of sodium fluoride, and then that gives me 2 sodiums on the right, so I'll put a 2 in front of sodium chloride, give me 2 sodiums on the left. Chlorine is the last one to check, and it looks like I have 2 chlorines on both sides.